a couple of words of introduction, and I'm going to admit people as they are coming. So I want to welcome everyone and to say how moved I am that we begin this online version of the Princeton-Bucharest seminar. As most of you know already, the Princeton-Bucharest seminar is an institution that has started almost 20 years ago. Next year, there will be 20 years of Princeton-Bucharest seminar. So far, we used to meet every summer in Transylvania. This summer, actually next week, we were supposed to meet in Venice. And of course, this is not going to happen. Therefore, we decided to move online and to replace our regular meetings with this ongoing weekly seminar. And we were very, very surprised, we being Dan Garber and myself and our help, Claudia Dumitru, who has been efficient in establishing a website and a YouTube channel. We were surprised and pleased to receive a lot of applications and a lot of interest. So we are starting this under very good auspices, and I hope it's going to be a great seminar. And I would like, by way of introduction, to ask Dan Garber to say a couple of words. So Dan.
Well, you basically said the important things. Our seminar normally in the summer would be 30, 35 people. We would get together for an intensive week of conversation and dinners and drinking in the evening. It was always, frankly, one of the highlights of my year to go and to meet colleagues from all over. This year, of course, we couldn't do it. We had planned to have a seminar actually with a group in the University Ca' Foscaro in Venice, but of course that had to be canceled. And we were looking for a way to continue the tradition. And this is what we hit upon. And in a certain way, I think it's an extremely interesting, and I think it's going to turn out to be an extremely fruitful extension of what it is that we were doing before. Instead of 30 or 35 people, we're able to have conversations with, I'm hoping, a lot more people. It looks like 70 or 80 on the Zoom channel today, and then a number of other people on the YouTube channel. So I would like to welcome you all here and hope that you will continue on with the series this summer. We had so many interesting proposals that we could not accommodate everybody for this summer. We are planning to continue on at least in the fall. Those of you who submitted abstracts and proposals but have not heard from us yet, will shortly get an email from us as we figure out what it is that we're going to be able to do in the fall. But welcome, and let me turn it over now to Marius and Katherine, who are going to be doing today's presentation.
Okay, well, thank you very much, Dana and Dan. And on behalf of Marius and myself, thank you to everyone who's joining this discussion. And of course, particularly to Dana and Dan for organizing it. For me, the origins of this paper go back, in fact, to the pre-history of the Princeton-Bucharest seminar, to conversations that Dana and I had about Descartes and Newton when we were graduate students. So this is back in the mid-1990s, shortly after Dan's book on Descartes' metaphysical physics came out. Dana and I tried to write a paper together, and we dared to send it to Dan, and she dared to invite him to Romania. And we all know what a fantastic thing they've built since then with this Princeton-Bucharest seminar. So a big thank you to them. Okay, to the paper, How Physics Flew the Philosopher's Nest. This paper is part of a joint project with Marius. About 6 or 7 years ago, he and I realized that we have a shared interest in matter theory and mechanics in the 18th century. And he comes to it from the end of the century through his work on Kant, and I come to it from the beginning of the century through work I've done on Newton. And we knew that something really interesting had to be going on in the middle, but we weren't sure exactly what. So now we have this big book project that we've been working on for 3 years called Philosophical Mechanics in the Age of Reason. And this paper comes out of that project. So what I'm going to do is give just a brief, maybe 10-minute overview of the paper, and then have discussion. We're looking forward to getting feedback on this. So at the start of the paper, we point out that at the beginning of the 18th century, physics was still a subfield of philosophy. And then the story we tell is about how physics and philosophy came to go their separate ways. And our central claim is that, perhaps surprisingly, at least it was surprising to me, collision theory is right at the heart of the action. So collisions turn out to have been a really big problem still in the early 18th century that no one had managed to solve. And what counted as solving the problem was the provision of a kind of causal explanation of the process by which one body acts on another, such that the rules of collision hold. So the rules of collision date back to the 1660s. And I thought, well, you've got the rules, you're kind of done, but that's not the case. So the attempt was being made to start from a theory of matter and show how you get to the rules of collision, much along the lines of how Descartes does this in his Principles of Philosophy. And Marius and I have adopted a label for this kind of integration of matter theory with results from mechanics. So the rules of collision in this case being the mechanics. And we call it a philosophical mechanics. And by the 1730s, no one had provided a successful solution. No one had managed to give this kind of integrated account, matter theory and mechanics integrated account of the collision process. And that it wasn't successful, that's not our assessment. This is by the standards of the people who were participating at the time. And for this, we've looked across the board. We've looked at people who kind of self-identify as more Cartesian or Newtonian or Leibnizian. Everybody's working on it. Everybody has some kind of theory of collisions. And as of the 1730s, no one had provided an account of collisions that was kind of widely accepted. And we think that there are 3 factors kind of going into what's making collisions such a big deal around this time. And one is the issue of intelligibility. So as you all know, one of the kind of big themes in philosophy and matter theory and mechanics in the 18th century is Newtonian gravitation and the disputes over action at a distance. And Leibniz, of course, had famously challenged the intelligibility of action at a distance. But once you do that, then those who take sort of mechanical philosophy and contact action to be the epitome of intelligible action, suddenly the spotlight's on that to kind of give an account of that intelligibility. And so, for example, in the 1730s, Maupertuis challenges his fellow French philosophers over that issue, claiming that action at a distance is no less intelligible, or action by contact, impact, is no more intelligible than action at a distance. And we just think it's intelligible because we're familiar with one thing acting on another by means of contact. So there are all sorts of issues about how do you what story do you tell that renders contact action intelligible? So that's one issue. Another issue is the intractability of the problem. I've already mentioned that lots of people tried to solve it, no one succeeded. The Paris Academy had 2 competitions in the 1720s on collisions. That didn't reach resolution. And then a third issue is the kind of issue of the reach of this problem and kind of how serious it is for the conception of philosophy. So as we'll all be familiar with, this is super important if you're kind of a Cartesian philosopher and you want to do natural philosophy. All of your explanations are going to be couched in terms of collisions, one piece of matter acting on another piece of matter by contact. But the problem reaches more broadly than that. Even those who adopted Newtonian action at a distance also still endorse collisions as a means of bodies acting on another. And also just the very idea of a body kind of reached beyond natural philosophy. So all of philosophy, to some extent, is engaged in some way with bodies, even if those bodies are human bodies. So if we think about human action, then for me to act on another body is for my body to in some way act on that body. So wherever there's human bodily action involved in some area of philosophy, we also have to think about bodily action. And this is something that was apparent to different people at the time, that the idea of body that's supposed to come out of physics, this sub-discipline of philosophy, this general account of body, in some sense was kind of unifying more broadly across philosophy. So if you take these kind of three things into account, the kind of breadth of the problem, the issue of intelligibility coming to the fore, and the long-standing intractability, then I think it kind of makes it easy to understand how this problem kind of seemed acute at the time. The next thing that we do in the paper then is, having set up this kind of background, is to talk a little bit about the seeds of change for the relationships among philosophy, physics, and mechanics that come about as the century progresses. And for this, we think that our framework of philosophical mechanics is really helpful. So this idea that a lot of the natural philosophers at the time and other people more generally were engaged in this project of combining matter theory, which comes from philosophy, with mechanics. And mechanics falls within the domain of the mathematicians. It's the mathematicians who are responsible for developing the theories of mechanics. So one route to this desired goal of the causal explanatory account of collisions would be, look, start from your physics as part of philosophy, use the resources of matter theory and try to recover the rules of collision. And this is what a lot of people were doing. And as we said, that turns out not to work out very well. So there's a second route available. You could start instead from the mechanics and see if you can get from there to an integrated account. And this is what Euler tried to do. Euler is an important figure for us in our book. He's a very interesting person who kind of spans both philosophy, physics, all of philosophy, physics, and mechanics. So the way that he approached the issue of collisions, and he was writing about this in the primarily in the 50s and 40s and 50s, was he said, look, we know from mechanics what the general properties of bodies are: their extension, inertia, and impenetrability. And from these, he says, what I can do is I can derive for you a causal explanatory account of collisions. And he changes a little what the criteria for that means to give a successful account. So I can get you a causal explanatory account of collisions, I can get you a physics of collisions, and I can also get you the generic rules of collision out of those properties. So I can give you a philosophical mechanics of collisions. And the crucial point about this for our purposes is that, as I was saying, for Euler, it's not from matter theory that we get the general properties of bodies, it's from mechanics. So for Euler, mechanics has authority over the properties of bodies in general, over our general kind of concept of body. And the upshot of this is that whereas at the beginning of the 18th century, physics, which was then the science of bodies in general, whereas at the beginning of the century, that was a subfield of philosophy, by the end of the 18th century, it's not. It's mechanics that we're looking to for the properties of body in general. And mechanics, as I mentioned, falls within the domain of the mathematician. And so physics is kind of easing its way out of being a subfield of philosophy. And this happens, Marius and I argue, because of the way in which philosophers failed to provide a philosophical mechanics of collisions, despite a lot of effort going into that. And also because during the course of the 18th century, rational mechanics makes enormous strides in solving all sorts of new problems. And Euler, among other people, explicitly makes the case for mechanics having authority over the general properties of body. And Euler in particular offers a philosophical mechanics of collisions on that basis. Okay, so there's all sorts of details and nuances and interesting connections to other figures like Du Châtelet, Hume, Boscovich, Kant, and so on. But I think that's essentially it. This is why, according to Marius and me, it's because of collisions and the problems with collisions that physics starts to fly the philosopher's nest. So that's my introduction.
Right, so you are opening the discussion therefore, yeah? For
Absolutely.
everyone. Oh, we already have a question. So Dan Garber was already having a question before even you finish your introduction. Dan?
Thank you very, very much, Catherine. I do have a question, which is why didn't it happen earlier? And what I have in mind is, to a certain extent, what it is that you describe as happening with the problem of collision in the early mid 18th century is not unlike what it is that happened with the problem of free fall in the earlier 17th century. And what I have in mind is really the sort of dispute between Descartes on the one hand and Galileo on the other. Descartes certainly was attacking Galileo. Galileo had no interest in Descartes, so far as we know. But the issue was this. I mean, you have Galileo, who offers in the Two New Sciences an account of free fall, beginning with mathematics. It isn't exactly rational mechanics, but what he's interested in is a mathematical expression for the relationship between time and distance fallen. And he is distinctly not interested in the causal process, the nature of matter, how it is that gravitation works. Descartes' response is, of course, that the only way in which we're going to solve the problem is by knowing what matter is and the mechanism by virtue of which bodies fall. And so there was certainly, for example, in the Mersenne circle, an enormous debate about that, that in a certain way continues through the 17th century. What you find then, and it seems to me that you have throughout the 17th century a kind of division between those who take the philosophy first, as it were, which is to say, you have to begin with an account of matter, what it is, and the mechanism of free fall, and those who take the mathematics first, like Galileo, eventually Huygens, and eventually Newton, of course. And in the Cartesian realm, of course, there was a lot of Cartesians who followed Descartes in this, ending, of course, with Leibniz and his account of gravitation. Why is it that, and it seems to me, first of all, do you think that that is in a certain way parallel to what it is that you're discovering in the 18th century? And if so, why it is that philosophy and physics didn't actually separate, or maybe they did separate with Newton?
Good, thank you. Yeah, so I do think that these two streams, it's clear, it's a continuation of this conversation that started in the 17th century. And very clearly, so Dana has done the work on the discussions in the 1660s in the Royal Society over collisions, where we see exactly this debate on the table, where some people say, we've got the rules of collisions, we're done. And other people say, no, I want to know how come the rules of collisions come about. Give me the matter theoretic account. So yeah, this wrangling of how to proceed definitely goes back into the 17th century, as you were describing. But I think some important things change at the beginning of the 18th century. So I think it is in the 17th century, you can still have some compatibility where you might think, well, I'm doing mechanics and my subject matter is bodies, whatever philosophy ends up telling me that bodies are. And that's fine. We can expect that at some point we will get a matter theoretic. If we want one, we can get a matter theoretic account of bodies and the ways in which they act on one another. So insofar as physics is about causes, then we're going to get a causal story out of that. What begins to change, what changes in the beginning of the 18th century is, well, now we've had almost, by the 1730s, 90 years of trying to do this since Descartes' Principles of Philosophy, and we haven't succeeded. We're also under a lot of pressure because we're making all these claims about the unintelligibility of action at a distance. Rational mechanics is beginning to develop the resources for dealing with extended bodies in ways that are highlighting the need for properties of bodies that were not really taken into account on the philosophical side. So the intensity of the problem and the need to resolve it, I think kind of it's all bubbling up. It's been there for a long time, but it really comes to a head as a crisis just before the middle of the 18th century.
Right, Marius has a finger on this, so a continuation of the answer. Marius?
Yes, thank you, Dana, and thank you, Dan. So if I could add a couple of thoughts to what Katherine has said. It's true, and you're totally right, that in the mid-1600s, there seems to be a bit of an emergent split between, as it were, the people who are interested in the mixed mathematics. I just want to study the proportions of falling bodies, as it, how distance changes over time. And I really do not much care about causal accounts. Perhaps it's because we don't have epistemic access that's reliable to such accounts, versus the strongly foundationalist Cartesian approach. And that seems to, up until 1673, when Huygens writes Horologium Oscillatorium, that seems to take off, because what Huygens seems to do there is, again, a continuation of the Galileo approach. Right. That's just like mathematizing phenomena of motion that Galileo did not, wasn't able to do. Right. However, it seems to me that that sort of split doesn't quite take off. The purely applied mathematics approach to these problems doesn't quite take off in the following sense. In Newton, for instance, by the end of book 3, you realize that he too is not just pursuing the study of mathematical proportions. That's a book in physics, and he claims that there are causes there at work. There's gravity acting. So once Newton joins the stage and the Cartesians hurry to react, you begin to see, as it were, it seems to me, a sort of abandonment of this like foundationally quietistic Galilean approach that's focused just on the kinematic surface of things, as it were. And you see, as it were, a competition between two causal programs, action at a distance gravity versus ether vortex. And this carries on until the mid-1750s. But they don't seem to think that, let's just look at the kinematics and how, space-time relations change. That's going to be good enough, it seems to me. They seem to agree that, yes, ultimately you have to answer what's causally responsible for these changes and how they might connect to like any notion of body, volumes of matter, things of that sort. And also, analogously, even some of the people who in 1668 make the quietistic noises, like John Wallis, for instance. People who say, look, please don't ask me about causes and how causes, are seated in matter theory. Here are the rules of collision. They're correct. It's just applied mathematics, QED. By the end of the 1690s, even John Wallis feels the pressure to say something about what the causal processes at work when a body meets a body, as Michael de la Rocca and Descartes put it. But you see that not in the papers he published in the Phil Transactions. You see that in the in the later work in Mechanica Sive de Motus, because there he too thinks I should try to say something about what causes these changes and how that how that could be at least prima facie integrated with a picture of matter. So again, as of 1700, I think that the dominant picture is they mostly agree that some kind of causal foundation in the manner of Descartes has to be given. The emergent split is between various groups who think that the proper foundation lies, here or there or in that other direction.
Right.
So the Cartesian program sort of carries the day, as it were.
Do you think even with the...
There are a number of questions here. I would like to introduce in the discussion now, because it seems to be connected, David's comment on the chat. I also wanted to expand on that, but maybe David wants to expand himself on it. So David Miller.
Yeah, I just was pointing out as a sort of minor follow-up to Dan's comment that you could actually push it back even further into the generation earlier. I mean, there's the divide in the Italian circle, in Italian mechanical circles, between people like Tartaglia and Benedetti, who explicitly reject relationship to philosophical reduction to matter theory and say we're just going to do rational mechanics and go our own way, versus people like Guido Baldo, who do seek reconciliation with some sort of Aristotelian physics. And just the point to link up with what Dan said, that that Galileo is something of a hybrid of that parentage. So it was just a tangential comment to sort of push it even further back.
But I think that that's important besides historical reasons. So I can connect with that by asking what other problems migrated from one field to another, from mechanics to physics, or from physics to mechanics, or from natural philosophy. So it looks like in between Galileo and Euler, all sorts of problems change places from one field to another. And the definition of mechanics, physics, and philosophy changed with each generation, isn't it, Katherine?
So yes and no. So I think my interest is really in the large scale shift that allows us, looking backwards, to talk about, the 18th century and classical physics and classical mechanics, and not realize that in doing so, we're making terrible mistakes, because mechanics and physics were separate disciplines still in the 18th century. And so yes, there's a shifting of problems and a moving around, but this is a really large scale kind of shift that we have difficulty seeing when we look backwards. That when you tell the story forwards, it seems very visible that physics, as the study of bodies and giving you causal knowledge about bodies and their natures and properties in the world, remained under the domain of the philosophers. Whereas mechanics was very much under the domain of the mathematicians, and it was only very few people who were both. And even the people who were both, typically, if they wrote about both, they wrote about them in just different books. So what really interests me is this, really kind of big scale shift in what counts as doing physics and its relationship to mechanics and its relationship to physics, and why that happened. And so yes, there are all these currents from beforehand, but why does that result in this big kind of disciplinary rearrangement after the 18th century? And when does it happen? What are the philosophical problems that are part of driving that? And that's where I think collisions have this really important role to play.
Right, another finger on this from Steve Nadler.
Hi, yeah, I'd just like to add a footnote to Dan's comment and make a suggestion for filling in that gap between Descartes and Leibniz. You say in the paper that for your purposes, the important point is that Maupertuis is seeking to put attraction and contact action on an equal epistemic footing, and sort of problematize contact action. I think of an analogous thing is happening in the 1660s with Laforgue and Cordemois, when they argue that mind-body causal interaction is no more, no less problematic than body-body causal interaction. What they mean is not that it's as intelligible as it, but that body-body action is no more intelligible than mind-body interaction. So you really see a nice, if you think of the mind-body case as analogous to gravitational action at a distance, which Descartes actually makes that analogy at one point, and the body-body case as a contact action, you have a nice analogous putting of the two problems on the same epistemic footing 70 or so years before Maupertuis.
Thank you. That's great.
Any comments on this, or shall we have the next question? Okay, next question from Des Hogan.
Thank you. Can you hear me?
Find people here. Yes.
Hear me. Thanks. So this is a question for Marius and for Katherine. I've been asking Marius about this, but reading the paper raised some additional questions for me. So the issue is the shift in the meaning of mechanical, rational mechanics. So in your paper, you point out that Leibniz says, you know, the explanation of gravity, according to Newton, isn't mechanical, right? You also say that Newton develops a rational mechanics. Now that sounds like the rational mechanics, as you understand it there, does include a theory of the action of bodies under forces of attraction as well as forces of impulse. If you go forward a bit to Kant, there is this ambiguity in the use of mechanical. Sometimes, for example, in the Universal Natural History in 1755, he uses mechanical explanation to include explanation that uses, you know, invokes gravity as an essential force of matter, the simplest mechanical explanation of the development of the universe. So in this sense, but he also uses it in this in this geometrical mechanical theory of matter, where it's a theory of matter he doesn't accept, where the mechanical theory of matter, as opposed to what he calls the metaphysical dynamical theory of matter, does not attribute real forces, and particularly gravitational forces, to matter. So I was wondering, in Newton's use of the term, first of all, does Newton use the term rational mechanics ever to signify a mechanics that includes the study of bodies under gravitational forces? And if not, when does that usage come about? With Euler, I think, is Marius was telling me, but if you could say some more about that.
Marius, do you want? Okay, I will. So yeah, Newton does use the term rational mechanics, and he explicitly sets up, I think what he's taking himself to do is to set up his own and proposing a new way of thinking about what he means by rational mechanics. And he does this in the preface to the Principia. And it is not restricted to contact action. So yeah, he's taking on, it's just this idea that you set up your axioms and you derive your results from these axioms. The axioms prove their worth by allowing you to solve problems that you're interested in, that you count as problems in mechanics. And yeah, this is, and then there's the connection to physics as the search for causes, which you join the two together by means of these axioms. So yeah, I think there's a very deliberate use of terminology, as there so often is with Newton, to frame what he's doing and carve out a new way of doing things. That was a bit compressed. Marius, I don't know if you want to say more, or does you want to come back?
Any follow-up on this, or shall I move to the next question?
That's very helpful already. Thank you. Thank you.
Got it. So I take Dana's point that, you know, at the level of definitions, defining terms kind of changes every generation. But with mechanics, because it was such a contested term, and because the underlying set of results of what got counted as mechanics changes so much over 80 years, I think it might be a bit of a hopeless enterprise to try and recover a single or even a main kind of sense of the term. And I prefer to, you know, try to suss out what mechanical might mean in an author or in a book by examining the surrounding envelope, as it were, the context, the contrasting sort of explanations, or the audience, the interlocutors he's dialectically trying to, you know, refute. Other than that, all the best we can do is just point to a whole cluster of terms associated with this attribute mechanical. For instance, before Newton and Huygens, mechanics had nothing to do with the study of motion, for instance. It was the theory of mechani, the contraptions. That's what mechanein, the ancient verb, the Greek verb that gave the term mechanics, meant originally to come up with a contraption. The 5, machines, as it were, the 5 rigid bodies used to move weights around in the, Earth's field of gravity. With Newton and Euler, the term gets, as it were, repurposed, hijacked from the study of the 5 Greek contraptions, plus Galileo's inclined plane, and comes to denote a sort of strongly quantitative, integrated, systematic study of motions, as it were. So it's not about using contraptions to move dead weights around on Earth. It's about the studying motions, and primarily the study of natural motions, the ones produced by natural forces, not by man-made ancient Greek contraptions or machines. And because of Descartes' program of constraining all physical theorizing to contact action, and somehow in England that gets called a mechanical sort of philosophy. Mechanical also comes to denote something that doesn't have anything to do with the study of motions or ancient Greek simple machines, but it denotes a sort of a constraint on research programs going forward, as it were. All action has to be contact action, and no action at a distance is allowed. So by the early 1700s, you have a cluster of meanings associated with the term mechanical. So I think the best we can hope to do as historians and try to zoom in on the particular context and try to infer meaning from use, as it were. So for instance, in Kant's work of 1755, I think his intent is to contrast mechanical explanations with explanation by divine action. Explanations that allowed for extra physical agency to come in and place stars or planets. But of course, if the contrast class is, material causal versus divine, action at a distance may well count as mechanical because it's just chunks of matter being responsible for, moving each other around.
Right. Just wanted to tell you that there are lots of questions. There is a discussion going on in the chat, which is very interesting, and I would like to bring it forward from the chat to the recording. So, and also a number of hands raised up. So may I ask everyone to just write in the chat what questions they have or whether the question is to the point so that we know how to arrange these questions. It looks to me that Enrico Passini has a question that might go next here. So Enrico, can you please, I have to find those for you.
Well, it wasn't really a question. Thank you, Dana.
A comment, yes, thank you.
Hello to all these nice people that I haven't seen in a long time. My remark started from a thing that Marius said about the cinematic surface or something like that. My remark was maybe what we perceive as a failure on the part of a certain party or a certain discipline or a certain development is just the fact that there is a very important success story that leaves any other possible failure or success behind. And the success story is that of analytical mechanics, which has its triumph at the end of the 18th century. So my remark started from an observation about the preceding century, but is in fact something about the 18th. And my suggestion was that maybe we can see this already in D'Alembert and in D'Alembert's approach to this kind of questions. And it's not so clear whether his attitude is more philosophically or mathematically motivated. So you also see somewhere blurrings between certain barriers that we can put as a division between different subject matters or arrangement of sciences or so on. So just this.
Right, any follow-up on this? then we have had at some point a number of hands raised. So maybe Niall Di Lucia.
Yeah, hello, can you hear me?
Yes.
Yeah, hi, Niall Di Lucia. I'm a PhD student from the University of Cambridge. Thank you for that, very interesting talk. I just had kind of two questions really, which are related. The first is on page 7, you say that in short, everyone needed a theory of collisions, which, of course, I agree with. I would just wonder kind of firstly, when you would say that everyone needed this theory, would it be in the 18th century? And secondly, and okay, I guess more importantly, for what reasons do they need the theory? Is it kind of because I'm thinking about in the 17th century, in the late 17th century, people are talking about the theory of collisions, Descartes, Hobbes, someone that I studied, Digby, but they're doing it perhaps not so much in the way of kind of wanting to necessarily enter a debate on mechanics per se, although that's in their kind of purview, but also to understand the theological implications. So, for example, Descartes wants to kind of study a theory of collision in order also to prove the immutability of creation, of God's creation. Hobbes is concerned historically with refuting scholastic notions of a theory of collision. And people like Digby, who I study in his two treatises, wants to save Aristotelianism by proposing a theory of a mechanistic theory of collision, which is also kind of square harmonizable with scholastic terminology. So I guess my two questions were, firstly, when you say in short everyone needed a theory of collisions, did they need, firstly, did you really see this need being, this need for a causal explanation of collision theory kind of coming to the fore in the 18th century? And secondly, you might not be so concerned about this, but are there a plurality of reasons why people needed a theory of collisions, not simply mechanistic, but also theological as well? Thank you.
Good, yeah, great. Thank you very much. So yeah, I do think, so the way I think about it in general terms is that in the 17th century, you can just sort of presuppose collisions as a means of explaining and investigating all sorts of things. And you might have, it's just a way of thinking about the world, a way of rendering all sorts of different things intelligible or probing things. It's only in the early 18th century, I think, that it really becomes in itself something that is critical as a target of needing explanation in its own right. So it goes from being something that we can just help ourselves to in order to do other things, all kinds of other projects that we might have, to being something that's critical. And you see that needs explaining itself. And you see this shift, I think, is kind of just quite pretty in the Leibniz-Clarke correspondence that begins with all these issues about God's action in the world and ends with the vis viva controversy. I mean, it ends, they get into it about how one body acts on another because of these issues of, well, how do we make sense of any kind of action in the world?
Marius?
Helps.
Thank you. Just a quick follow-up in response to Niall's question. So in one way, our lower bound, our terminus a quo, as it were, is the year 1668. That starts our story going forward, as it were. So of course, there are very interesting, deeply foundational debates about, the status and the intelligibility of collisions before then. But we had to choose a date, and the date got decided by the key problem that we tackle in the paper. And secondly, after the 1670s, it seems to me, again, there are real experts in the audience, so they might well correct me. But the mid-century attempts to try and show that, a reformed Aristotelian foundation, as it were, can well account for, action by contact and a mathematizable theory of impact, they sort of like fall by the waysides. They don't keep center stage anymore, as it were. But what seems to, move to the center is the program that Oldenburg very pithily and concisely makes clear in a wonderful quote that Dana Jalobanu found and put in her paper, to give some kind of a causal story that explains why the rules of impact are the way they are. Why those rules?
Thank you.
Right. Thank you. I think Hanok is next.
Thanks very much. I need to unmute. Okay. First, thanks very much for your paper. I've learned a lot about the thought on collision. I knew only a bit here and there, so it was really very interesting. But I have a more general question about the nature of the project. You say that the disciplines today are distinct. We have our own journals, own conferences, and so on. When did this happen? Now, what exactly are you looking for? People making a contribution, an influential, decisive contribution to physics without making at the same time, engaging at the same time in the same project in philosophy. So we have this already with Galileo and Huygens and Newton. And you can say even earlier, you go back to the Middle Ages, Nicole Orem makes contributions to physics, which are separate from contributions to philosophy. So in the sense of important contributions to physics, independent of philosophy, we have it even earlier. In the sense of physics becoming independent of philosophy, this hasn't happened. We have to this day conferences attended by both physicists and philosophers. We have journals to which both philosophers and physicists contribute. We have the Foundations of Physics, founded by Rovelli, who is a big name in physics, but to which both physicists and philosophers contribute, and they refer and discuss each other. So an independence of the disciplines didn't happen. If you do exoplanets, you don't do philosophy, fine, but in much of physics, you do philosophy. And on the other hand, contributions to physics independent of contributions to philosophy go back at least to the early 17th century, and I think even earlier. I've mentioned Noem, and one can come up with other examples. So what kind of split between disciplines are you after? Because you've shown, that's okay, you've shown how the work on collisions split, but that's one specific case, and it's not the general question with which you open your paper. Thanks.
Katherine, Marius?
Okay, so yeah, good. So there are a lot of moving pieces here, right? And so the labels for which we use for the different disciplines and what falls under those disciplines, a lot of different moving pieces. So we have to make some simplifications and hold some things fixed. And one of the things that we hold fixed is what physics was taken to be at the beginning of the 18th century by a large proportion of people. So even there, you're not going to find everybody agrees about what physics is, but we take physics at the beginning of the 18th century in the sense of Muschenbroek and others, that it is that branch of philosophy that studies bodies. So all the bodies there are in the world, the space of the world, their causes, natures, properties, powers, everything like that, so things get carved up differently. We can't assume that the kinds of questions that we ask today are the same as the questions that were being asked then. So we do our best to locate ourselves at that point and understand what was meant by physics then, and follow what happens to that idea. And then there's some contrast work to be done with what falls under what counts as physics today, what falls under the umbrella of physics today. Again, oversimplified, so my background is in philosophy of physics, so I'm kind of very attuned to this feeling of, well, here's what I do, and it's a single thing, and yet it seems, at my university, the physics department's on one campus and the philosophy department's on another. So something interesting and important happened. So yeah, oversimplifications, but we take that notion of physics, which is a particular notion not agreed by everybody, and look at what happens to the problems that fall under that. And we find that it's people working in mechanics, on the whole, a different group of people who then claim by the end of the 18th century that they are the ones who are in a position to tell us what the most general properties of bodies are, not the people who call themselves philosophers and do what was called physics at the beginning of the 18th century. So it's that, how that happens, what philosophical problems drive that we're most interested in. So yeah, there's this kind of big broad brush painting that is kind of inevitable, I guess. And then the real nitty gritty work is in those shiftings of who gets to ask which questions and claim authority to be able to answer them. I don't know, I hope that helps.
I think it's worth staying here a bit more and ask Michael Steltner comment, who had a very interesting comment in the chat. So Michael, would you like to say it? You have to turn on your mic. It's off, right? Yes. And we are still not hearing you. No. We see you very blurred and we don't hear you.
Okay, do you hear me now?
Yes, we do. Great.
Okay, sorry for that. And I'm blurred because the camera had a problem. I mean, that's a fascinating story, that this is such a long story of, and I speak in 20th century terminology now, of a problem in the science, and where philosophers agree that they expect the answer from the science. But on the other hand, and I heard this in Stan's comment, I mean, there are various things that happen side by side. So there's a change in terminology, what the Germans would call Begriffsgeschichte. There are changing disciplines, etc. So it seems that if you have this more modern agenda where you really want to tell present day philosophers of science, look, there was an interesting epoch where philosophers thought the solution of the problem would come from physics, that you might look at that figure that 20th century debates often had, that they said, yeah, well, this general philosophical question ran into a certain crisis and it required a new foundation, ein Wiederaufbau, using this Carnapian word. And you can, of course, tell this story very well about Euler, and that's the debate where people have at the abandonment of the mechanical worldview. So, and that's the question what I want to press a little bit. Would you say, was there a specific point, did the sense of crisis change, or was it just one of those problems that was always sitting there? Because I mean, problems can sit there. Even Newtonian mechanics cannot solve the problem of collision itself. So of mass points collision, it cannot solve. So was there a point where you would say you pinpoint the time of crisis?
Katherine, Marius?
Yeah. I wish it would be easy for us. It would be a happy day for the interpreter to come across this kind of smoking gun evidence that at least narrows the, the temporal zoom, as it were, to this is when, it became clear to them that, they had a real crisis on their hands. But as Katherine said, Euler was a bit of a dual figure. He can't really be, we can't really call him the sort of person that decided, enough with this, philosophically derived matter theoretical pictures of the essence of body and how that's supposed to be a foundation for rational mechanics. No, now we're just doing, mathematical physics. He's not that sort of a person. Not when you take in the entire, as it were, the entire oeuvre, the whole output of Euler, because there were pieces that he didn't quite get to publish, or that are less read, in which you see a very different Euler as far as this program is concerned. The same goes for Lagrange. You read, you think, oh, the book from 1788, surely that has to count as some kind of a watershed change, because in that book he says you won't find any diagrams, any pictures, and also you don't see me do any matter theory in it. I just delve straight into the dynamical laws. Here's the principle of virtual work. Here's how you derive equations of motion. But that's not the full Lagrange. There's the Lagrange of around 1800s and the early 1800s, when they start wondering, but the principle of virtual work, is it an axiom? Is it a theorem? From what deeper foundations can we derive it? What counts as the evidence for the, a priori truth, as it were, the unrevisable truth, this principle? So there you see the, heavily philosophical Lagrange, not so much in a metaphysical vein, but, trying his hand at the epistemology of, rational mechanics. So I'm not, I can't say in good conscience that there's some kind of a bright, moment in time when it's become clear that a crisis is on, there's a crisis on their hands. But it's something that I haven't fully discussed with Katherine, so she might have very different, feelings on this matter.
Right, we have a trend of questions on action, another trend of historiographical question. At some point, there were fingers raised on Euler and inflection point. So maybe Julia wants to do the finger question here. Julia.
Yeah, thank you. It was a very nice paper to read, and I would just point to one worry about the historiographical situating of the paper beginning with the story we tell ourselves. And it seems to me that Marius and Katherine take the narratives of the scientific revolution as, let's say, the culprit that that give the impression that physics and philosophy parted with Newton. But I was wondering whether this heritage that we have in terms of historiography doesn't include other strands as well. Like, for example, there are historians who look back at the history of physics and want to tell the story of how this exact science has been dealt with from the moment when it became mathematical, when you have a mathematical language to express it. So it seems to me that they are making a choice, an implicit choice, and I'm referring to stories being told by Mach and also by Truesdell, who doesn't agree with the supremacy of Newton in Mach's story. And Truesdell says, actually mechanics was developed in the 18th century, or at least the mechanics that is relevant for what we know today mechanics to be. So I'm curious where you stand on this point about the different historiographical strands that might have given us this view.
Good. So there are many different ways to kind of approach your question. So I'm just going to pick one thing, which is to say, yeah, we picked, this is an autobiographical artifact, right? So we pick the story that we received as the standard story. And one very important thing we should do, so when we're thinking about our target audience, what we have in mind is the reception of this story is we should absolutely add something about a lot of all the work that has been done to both reject that story or to make it more complex in various ways. So yeah, it's a launch point, that claim. And the second thing that I want to say is that then, we then tell a story, but our story is a story made on the basis of things that we're interested in today, right now in the 21st century, and that we bring to reading that history, and we look back to read it, and then we try to read the story forward. And of course, it's a story told from our vantage point with interests that we have. So the goal would not be to replace the story that we received that we think is wrong with another story that's the right story. I mean, so that's kind of the narrative gloss over what's happening. What's really going on is the philosophical work in terms of look at this interesting problem and look at the ways in which to solve it and look at what next moves that results in being made with respect to these questions that we bring that are interesting and that we can see taking place in that period. So in terms of methods and things, there's, yeah, you're absolutely right to point to this kind of rather sort of trivial, if you like, way of introducing things, but I hope that the content of the paper is deeper than the introductory whoosh at the beginning. Marius, I don't know if you want to say things about it, but yeah, no, we should definitely add some stuff at the beginning in response to what you said. Thank you.
We had another finger at some point from David Mokima. David, is it fitting here?
Yeah, I think it does fit here because I think I appreciate the distinction that you're making between rational mechanics and philosophical mechanics, and I believe that's helpful and right. So my question I had was, what sort of authority do you see rational mechanics having on our theory of bodies? I see on page 15, you mentioned that there's still some work to do in the epistemology, but on page 16, you say that it is Euler's treatment of collisions, which presupposes rigid bodies subject to highly idealized conditions. So it sounds to me like the idealized conditions are not placing any constraint on bodies themselves. It seems like they are just idealizations. So perhaps I wanted to hear more about the kind of authority that you're taking rational mechanics to be playing.
Good. I feel like I'm talking a lot and Marius should talk more, but okay. So yes, good. So one thing doesn't come out very strongly in the paper is that there are two elements to what's going on with Euler. One from the physics side, where he says, look, here's some things we already know from mechanics. And that is that bodies, whatever they are, they have these general properties. They're extended, they have inertia, and they're impenetrable. And that's all we need in order to develop a physics of collisions. However, and we take those from, so that mechanics has authority over that. However, other element of what Euler's doing, he's working out irrational mechanics, and extended bodies are really, really, really difficult to treat in rational mechanics. And the 18th century is struggling to deal with that. And the time that Euler works out his physics of collisions and his philosophical mechanics of collisions, the rational mechanics of extended bodies doesn't exist. So it's kind of a promissory note that, and in time we'll be able to give you a full account of these bodies from mechanics, but we can't do it yet. But we already know enough to be able to give you this, what you're looking for as a physicist. Marius, do you want to?
Marius, comments? Marius, your microphone is muted.
Yeah, sorry, not so much. Maybe just a quick add-on. One thing that perhaps we didn't, we had to keep the paper within manageable bounds. So one thing that we didn't spend a lot of detail explaining is that, so what we call the problem of collision, because we approach it from, first year undergrad courses in physics, is the problem to predict the speed, the post-collision speed and direction, the velocity of one point in the body, the center of mass. But real bodies are extended. So when they collide, there's all kinds of additional motions there. There's deformation, there's rotation, there's like slow down and speed up due to friction. So when you deal with extended bodies that resemble the real bodies around us, collision theory becomes even more complicated, enormously complicated, on the purely rational mechanical or, you know, quantitative side, as it were. You need, there's the need to introduce additional parameters, ways for that extended object to move and deform that's simply not captured. It wasn't on anyone's radar in 1668, or even for the next 50 years after the Royal Society competition, because they had no idea how you might even begin to get a mathematical handle on these difficult aspects. So that's rational mechanics too. That's something that only the best mathematicians in the 18th century, you know, find the courage to, you know, try and tackle. And then in turn, that's an aspect of, you know, collision theory 2.0 that calls for, you know, being connected back to a matter theory, to a causal account of how bodies, extended bodies, deformable or rigid in this case, are able to act on each other as extended objects.
We have a number of questions on the, as a follow-up of Hanno's question on the relation between physics and philosophy. So Miklos maybe is next on this. You have to turn on your mic, Miklos.
Just a very short comment on Hanno's comment, which I thought was very important. I mean, he claimed that physics and philosophy have not in fact separated. And we claim that it would be then therefore also problematic to assume that they were separating in the 18th century. I think this is correct, but the way I understand the claim which is made here, to put it very, very roughly, and I'm wondering whether this is a good reading or good understanding of what you're claiming here, is that physics left the nest of the philosophy, not when physics left philosophy totally in the sense of being independent of it, but when what happened was that physicists have turned themselves from one kind of philosopher into another kind of philosopher. That is to say, when they turned themselves into a positivist philosopher rather than a metaphysician one. Because of course it is enormously difficult to give an explanatory story about why the collision happens the way it happens, assuming theories of matter, theories of bodies, and all these extremely complicated and metaphysically charged theories. Rather, let's just concentrate on how an elastic collision happens. Let's describe it. Let's remain on the surface of the phenomena, and then let's just happy with that, and that's physics. Would that be a reasonably rough summary of what the philosophical change is at the time when you're talking about physics leaving the philosophy nest?
Maybe I can try to say a couple of things in response here. So I'm not sure that I share the presupposition behind this question, because I think that attempts to connect, you know, a rational mechanics, as it were, kinematics of collision between extended volumes of matter, chunks of stuff that have a size and a shape, connect them back to a matter theory, but in this time it's an experimentally confirmed kinetic theory of matter. These continue well into our time. I mean, 7 years ago, a whole monograph came out that's trying to give the kinematics of continuous bodies, to connect that, to obtain it, you know, by mathematical techniques from an atomistic, a mass point foundation as given by the kinetic theory of matter. So yeah, if we focus selectively on, you know, what various, you know, people, discrete individuals at discrete times might be researching or publishing on, it seems as if there's mostly this like positivistic game of, you know, just derive the equations of motion and stop asking questions. But again, if you take this long durée, if you zoom out and take a few steps back, you can tell that this is not really, even in the 21st century, at least in the, classical physics part of the discipline, it's not the whole game anymore. They're not happy to just, do positivistic mathematizations of, motion changes as given to the senses. That's far from it.
I think we can still stay at this historiographic point because we have a number of historiographic frameworks. We have a number of questions here, but I think that they started in Catherine Dunlop's questions. So Catherine, would you like to be next?
Thanks. I'm actually preparing and serving lunch, so I'm listening, but I can't read it out. Thanks.
Okay,
so I read Catherine's question, and
okay.
I
want to comment on that, or shall we leave Bibi Shank to come next?
So thank you, Katherine. I take your point.
How about reading it loud for those on YouTube?
Okay, good. It was high up. Okay, so Catherine's question. I think this is another way of raising Enrico Passini's question. I'm interested in how the mathematical frameworks within which results were derived from first principles changed over the course of the 18th century. At the risk of oversimplifying, one could say that by the end of the century, physics was done by solving equations, which was certainly not true at the beginning of the century. In important cases, these were functional equations. So the problem was specifically to find a function possessing certain properties set by the conditions of the problem. In this new context, it seems harder to see where matter theory enters in. I'm wondering whether the emergence of analytical mechanics is just a parallel development to the one you were discussing, or if there is any connection. So I think that, again, there's a strong temptation to say that if you look at the canonical textbooks, as it were, there's no overt official discussion of what the matter theoretical presuppositions or the backdrop picture of body behind these differential equations is. But you can still recover commitments to a notion of body or a theory of matter from the mathematical formalism, as it were. So here's an example, and I apologize if it's a bit like nerdy and technical. If you take Cauchy's laws of motion, they're just differential equations. They tell you how the total force on the body changes the motion of the body. But here's the problem. If you take the equations that describe the change at a point, the so-called local form of the laws of motion, there are two kinds of, force quantities entering there. One is the B quantity that denotes the gravity-like action at a distance forces. The other one is the T, the stresses, as it were. Well, that shows that you're committed to a picture of body as a deformable continuum, because rigid bodies and mass points, the other two pictures that you could embrace, don't support stresses. To talk about stresses in mass points or in rigid bodies is meaningless. It's not well defined. So when you inspect just the mathematical form of those laws of motion, you can suss out, you can discover commitments to a certain picture of body, to a certain view of what matter really is like at fundamental levels, an architecture of matter. And there are three, pictures of possible architectures, still, butting heads, as it were, still trying to compete for supremacy. They become more difficult to see because, again, not always, especially in these textbooks, which are written for graduate students primarily, these textbooks don't spend much time making overt and defending the philosophical and matter theoretical commitments that these, what looks like purely formal, highly analytical theories of mechanics are wedded to. So I hope that does a little bit to But this goes somewhat to a methodological point that we should have made early on. When the words aren't there, we're committed to recovering meaning from use, as it were, from detecting the various ways in which they meant key terms or the background assumptions that they took for granted, from the way they use the formalism, as it were, the mathematical representations, whereby they seek to quantify collision processes.
Right. Let's have a follow-up on this. Dan Garber.
Just a very short question. Through all of this discussion, I'm not sure, when you're talking about the distinction between physics and philosophy, and whether physics is still in philosophy or not, what do you mean by philosophy? I do think that philosophy is, throughout this period, a moving target. It's a historical category. When you're talking about the distinction between, say, philosophy and physics in the 18th century, you've been looking on the physics side. I think it's as much on the philosophy side that you have a change in what it is that the discipline is. And then in addition to that, of course, there's also the institutional issue. When you're thinking about the distinction, I think Katherine mentioned on her campus, the physics department is in a different building from the philosophy department. That is not an irrelevant consideration. To think back, also philosophy is undergoing institutional changes, and the universities are evolving, and scientific societies are evolving as well. And it seems to me that that really complicates the question enormously and makes me wonder just what is the question that you're asking when you're asking about the distinction between philosophy and physics.
Yeah, good, thank you. And that goes a long way to explaining why we've already spent 3 years writing this book and we're only halfway through in comparison to this very short paper. So what we've looked at is how people self-identify. So whether they call themselves a philosopher or a mathematician, and we've looked at how they identify in the titles and in the papers that they write and so on, what it is they take themselves to be doing, what labels they themselves use. We've looked at the kinds of questions that they try to ask and the kinds of answers that they offer and how those relate to other people. So you can put them in groups and people label things in a certain way. And we've also looked at institutional relationships and that kinds of thing. That's something we've just been working on and looking at more recently, the ways in which that reinforces divisions among groups of people in particular ways. So yeah, I think all that's right, but I do want to just make very clear that in using these labels of physics and philosophy and mathematician and mechanics, we've tried very hard to use the labels that people ascribe to themselves and then to look at what they're actually doing when they're working on things, what they take to be problems, what they take as succeeding in doing things on their own terms, to try and understand what these projects are. And just to go back to what Miklos was saying, I think this is really important for thinking about what we mean by physics. So we're taking people at their word in terms of what they mean by physics and what kinds of activities go on under the label of physics. And that includes connecting up what you're doing when you're thinking about bodies and their properties to matter theory. And it also means, it's two elements to it. It also means trying to give a causal story for bodily behaviors in the world. And those two things persist through this increasing use of mechanics and analytical mechanics to do the treatments of various kinds of material systems. So people are still looking for, okay, what's the connection to matter theory? Not everybody, but most of the people that we're looking at, and what's the connection? Can we tell a causal story here? So in that sense of physics, which is how the people at the time describe what they're doing, that persists through the mathematization in interesting ways, I think.
I think Katherine Wilson, your comment was to the same point, isn't it, Katherine? You need to turn on your microphone.
Sorry, my comment about Miklos shared. I thought one relevant thing something that hasn't been mentioned is the philosophers of science, and I was thinking here of D'Alembert, sorry I didn't spell that, and Buffon especially, who were very influential in the preliminary discourse to the encyclopedia, in Buffon's first discourse. They're all saying, forget about the essence of matter. We don't know what it is. We only know what it does. Let's just, as other people have been saying, stay on the surface and correlate phenomena. We don't understand causes. We understand correlations.
So yeah, good. So yes, good. So there's all this discourse going on, and we're looking at that, and then we're also looking at, so I've been reading D'Alembert's treatise on dynamics and solving the problems, the 14 problems at the end, and looking at the resources that he needs to solve those problems and what he's helping himself to in terms of the properties of bodies and the characteristics of matter that you need in order to solve those problems, and what he has to say about those properties. So he'll talk happily about extension. He doesn't talk so happily about mass, things like that. So looking at, as Marius was saying earlier, not just what they say, but also what they do to try and understand what's going on with how he gets in people. So one of the very late problems is collision problems. How does he build up to that? What does he need to introduce conceptually in order to have resources to deal with collisions? And what does he have to say about the status of those resources?
And perhaps another element is nutshell theory and attempts to reduce matter to just combinations of forces. So you get rid of this solid matter altogether, which a lot of people find very philosophically exciting because they think that this solves the problem with the soul, something like that. I'm thinking of Priestley, for example.
All right, we have a number of people waiting for a long time, and I apologize for this. G.B. Shank.
Hi, yeah. So I want to go back to Catherine's point, a number of points in which she said, among other things, that she's a philosopher working in a historical way. The challenge of working historically is keeping track of all the moving pieces, the complicated presence at any one moment of all kinds of competing claims and dynamics. The need then to simplify, that one can't try to capture it all, that history is not a mimetic mirroring of things. It's about a set of judgments about what matters most and following strains of argument and debate and things like this. And that especially what one ends up with as a historian is a story that is produced by generating judgments about what matters, where are centers of gravity, what's peripheral, and that you're very open about the fact that this is your story that you're telling, and that there are other stories. And as you know, I'm sure, I have a very different story about all this. And yet we could go on forever arguing as historians about the different judgments you make versus the ones I make. And I guess that's not where I want to go. I want to ask you as a practicing historian, and Marius too, about the formation of your story and what's at stake. A dictum of historians that I particularly adhere to is that there's no such thing as history out there separate from the historian who's putting it together. And that your story then is written from your point of view, and is addressed primarily, though, to philosophers, and is wanting to marshal this evidence and assemble this historical account to, I imagine, do some historical or some work in the present with philosophy. And so I guess I would be curious to hear you, and Marius too, talk at greater length about what's at stake here. And in particular, as a way of maybe framing it, I think the one thing I found almost everything that I read in the paper perfectly agreeable to me. What I would argue with you all about is what you didn't include and what you left out and all the ways the story could tell. But the one thing I did sort of struggle with is this metaphor of physics leaving the philosopher's nest. And kind of picking up on what Dan said, it strikes me as a metaphor that seems to suggest, but maybe this isn't right, a continuity of the philosopher's nest through all this, that there is this sort of thing out there, the philosopher's nest, which you as philosophers see, and that the idea of a story about physics once being in the philosopher's nest, but then flying, off to become its own bird, I guess would be the continuation of the metaphor, is one way of describing it. But another would be to say what happened, as Dan was sort of suggesting, is that all these categories got transformed, and that what was natural philosophy into the 17th century came apart, and out of it came maybe a new thing called philosophy that was distinct, and also a new thing called natural science, and maybe a new thing called theology, that were all distinct in this way. And that would lead to a very different story than yours about physics once being in the philosopher's nest and then flying it, while the philosopher's nest, I take it, continues to exist right up to the present. So using that philosopher's nest image as maybe a focus, could you just say more about what for you as 21st century philosophers is at stake in this storytelling, is sort of the project here? Now, just one last thing. My response to Hanok's point is to say, I think it looks very different from the United States, the relationship of physics and philosophy, than it looks in Europe. That there's a very different kind of dynamic between the two disciplines in Europe than in the United States. And so again, this might be an American, a United States story or not. So
I think, Marius and I have different biographies and different takes on this, so we should each go quickly. So the kind of first level thing is, here's my interest in it. I am really interested in philosophy, in physics as a way of learning things about the world, and I'm interested in, so what's the subject matter of physics and how does it come to be about the things that it's about? And this goes all the way back to that first paper that I mentioned earlier that Dana and I did many years ago about, well, what are the bodies that are the subject matter of Descartes' laws of motion? Then the meta level kind of thing is, well, here's an interesting thing. I have all these questions as a philosopher of physics that I'm interested in. And in contemporary culture right now in the UK, which is where I was educated, these questions, who takes it to be their responsibility to be able to answer those and have authority with respect to answering those, are two groups of people who by and large don't talk to one another and don't expect each other to have relevant things to say with respect to each other's questions. One is my colleagues in the philosophy department, another lot is my colleagues in the physics department. And there was a time that we're all familiar with when the very same people took themselves to have authority with respect to those very general questions about what's the nature of the world, how does it work, what are the causes, what's the nature of substance, all that kind of thing. Was one person could do all those things and do political philosophy and do moral philosophy and do all this other stuff. That's not the case anymore, and I have to go to different places and there are these disciplinary distinctions now that didn't exist then. And that is true for all sorts of other disciplines and things as well, but it's particularly interesting to me because the question that I have, the first level question, is one that requires knowledge of what have become these two different sources of authority. That's my answer, Marius.
Yeah, very quickly, my initial driving interest in these matters was dual. One was a conviction that the old story that after Newton, it was all Newtonian mechanics and it was normal science, and that somehow grew imperially into the whole of classical physics as false. And various people in the last 10 to 15 years have tried to done outstanding work to demolish that story. I mean, JB himself has contributed to that effort. The story is false. But an interesting question would be, so what's a better story to succeed at then? And from that angle, I see myself as a sort of like heretically in the wake of Clifford Truesdell, because Truesdell himself had an agenda. He hated Lagrange and the French school that came out of Lagrange's work. And he gave this like disingenuous impression that all you need to do to understand what happened to classical mechanics after 1687, all the way up into early 20th century is read Euler. And it's all in there, and Euler is solely responsible for that. But that's also false. That's not true. So even at the level of rational mechanics, never mind the foundational commitments, there's a gigantic split between two very fundamentally different ways of going about the business of rational mechanics. One is due to Euler, and you can call it like in a very, if you feel extra generous, you can call the Newtonian approach. The other one is due to D'Alembert and Lagrange, and it's completely different from anything you see in Newton in Euler, completely different. So I would like to use these, these researches as, stepping stones towards maybe some of our better grad students, when they grow into, full-fledged scholars, will be able to tell a new story that takes in, more facts. It's easier to defend as, sound judgment. We all make up our stories, but surely we hold each other responsible for the stories that we tell. So then, seeing as the old story, Newton did it all, moving on, it was normal science. That story is false. We know that now. So the question is, what do we tell our undergrads when they ask us, so what happened?
Right. Katherine had a follow-up on this.
Oh yeah. Oh, so just very quickly also, I am, not a historian, I'm a philosopher, and I take us to be writing a book in philosophy of physics that takes place in a historical period that means that we need to learn from people like JB and others about the, just the difficulties of doing that. But our audience is philosophers, and I take it that we're doing philosophy of physics.
Monica Solomon had something to say about what is at stake here. So Monica.
All right, I've unmuted myself. I hope you can hear me.
Yes, we do.
So I like JB Shank's question about what is at stake. And I was wondering whether, it's all on just Katherine and Marius, basically, to answer that question. It's like with every book that you read, especially ones that they're in your own discipline, ever more so the ones that you write, you have to ask what's at stake. And the answer, I think it's like depending on each of us to have something to say, especially to the students, be them undergraduate or graduate students. So if we have a story to tell about the physics and philosophy, then that will immediately impact on how we teach undergraduates, and whether we think that, say, students who are majoring in philosophy, for instance, should be interested in physics texts, old physics texts, and vice versa. Whether training physicists should maybe, require them to read a little bit more philosophy. So, and how you'd go about that, it's hard, right? You can't just pick texts and say, oh, I think this is important. So you have to have a story to tell. And I kind of find interesting in Katherine's and Marius' project, the way it can lead people who have no idea what was going on in the 18th century, who think they know what's going on today, and to discover kind of new things in a landscape that they might find attractive. So yeah, but that's like the story that I have to tell myself as well as and people who are teaching. So thank you.
Right, there are a number of other questions, and I would like to, well, I don't know how to order them. There was at some point a follow-up by Bill Harper on D'Alembert. Bill, do you want to take it now? You need to turn on your mic.
I wanted to say, one of the things I wanted to point out, a contribution to what we would call physics that D'Alembert made that was really important was when the discovery of nutation, which is a small variation of varying in the earth. D'Alembert was the first one. Now he was using he was using analytic procedures to do it. But what he got was an account of this that gave the first accurate measurement of the mass of the moon. Newton had attempted to get it from the tides and he had it way off. And D'Alembert really got the first accurate one. And then he went back and he used it in getting a deeper account of the whole long precession of the equinox. It's a huge long period thing. And that's sort of, look, that's, I want to suggest that's the part of it that Katherine, that would be the physics part. And there's this connection with getting at, and one of the things about this measuring the mass of the moon was this is not just correlation. He can get at the cause that the moon is approximately 1/80 to the Earth rather than 1/400 or whatever it was Newton was trying to get, is a causal factor that's making a difference. And I think that that's a really important part of how we can get at and use this rational mechanics stuff to get at the world and understand it better. And notice that's quite separate from the, okay, well, no, I'm gonna leave that, stop with that.
Katherine?
I just want to say, yeah, thank you. And yeah, these questions about the relationship between the mechanics and the physics in Newton's Principia and how that's then that methodology that you've written about so beautifully then goes forwards into questions. So D'Alembert's rejecting forces, does it mean he's rejecting causes? All those kinds of issues need to get worked out.
Right, I think we have a separate strand of questions, although remaining within the same problem of the relation between physics and philosophy. So let's raise to a meta level and think about the historiography of this problem in the past. So when you first announced the title of your talk and before even reading it, I said, well, that's Husserl here. You know, that's a 19th century idea that sciences got separated from the body of philosophy. Slightly different, we have Joshua Eisenthal and Diane Bika saying, having something to say about other historiographic frameworks. So Joshua, if you want to speak now.
Thanks. Yeah, thank you, Katherine and Marius, for this really interesting project. So really, my question is just that I'm curious what you might say to apply this to some of the things in the 19th century, if you would be tempted to do that. And in particular, how you might apply it to the sort of theorizing about the ether that was happening late 19th century. Because on the one hand, that might look precisely like a kind of perhaps a return to philosophical physics, as I think you defined it in the paper, where you've got something that's offering itself as like a fundamental theory of matter that would itself accommodate what was within the remit of mechanics. Or you might say, and perhaps I'd be more tempted to on this latter option, no, that's a theory of mechanics that really sits within mechanics in certain ways and is just like an attempt to reduce electromagnetism to mechanics by showing how you could get Maxwell's equations from a mechanical model of the ether. Or something else entirely.
We'll see what Marius has to say. My position at the moment is I don't know. And that's partly because of how much I've learned just by trying to follow the things that I'm interested in forward through the 18th century and how much has depended on just the tiny details in the problems that people were trying to solve and how they went about them, watching their methods in practice that yeah, I don't know until I get there, but I would like to get to the 19th century. In fact, I'd like to get back to doing contemporary philosophy of physics, but it's a long journey. So yeah, I don't know is my answer.
Marius?
Yeah.
Marius, you have your microphone turned
Yes,
on.
sorry. Thank you, Josh. I love the question, and I read it some 10 minutes ago. I was spinning my wheels about it, and my first impulse was to say the first. Your answer is, your first suggestion seems right. But then I thought about it a little bit, and I think I want to take that back. So I wouldn't see these late 19th century projects as a return to philosophical mechanics or, you know, a generalized philosophical physics, as it were, for the following reasons. So I see these mid to late 19th century matter theories as being driven and defended primarily by empirical concerns from empirical sources of evidence. So it's no longer the case that the natural home for matter theory had to be the ontology of body, as it were. This heavily conceptual, partly armchair, you know, speculative, defended account of, you know, the most general properties of matter. It's, you know, here we were able to turn heat science into proper thermodynamics. And we have, you know, several theories about crystal structure, you know, fine structure at molecular levels. And they're all like inferences to the best explanation from experimental data, as it were. So that's what gets counted as matter theory from, you know, Clausius and, you know, these like mid-19th century, you know, heat science people onward, as it were. You can't call that, you know, Then when you try to show that other branches, more overtly or purely mathematical branches of classical physics, when we can link those back to a picture of matter, I don't see that as a continuation of this project of a philosophical mechanics anymore. I think your second suggestion is more correct. And I'm saying that because already in the 1830s, with the, you know, Poisson school and then its offshoots in Germany, you see this attempt to like articulate what they call a mechanical physics, namely to really show that you can get, for instance, the heat diffusion equation from, you know, pure mechanics commitments, as it were, or that you can get accounts of, you know, double refraction, for instance, the Iceland spar, for instance, from, you know, pure mechanics, as it were. So I think your second suggestion seems more right. But again, apart from you and Bill Harper, nobody in this group is an expert in, you know, late classical physics. So there's only so much we can say to you know, to answer this question.
That was very helpful. Thank you.
Michael Stelzner has a follow-up on this.
Basically, what's in the comment in the chat, isn't it that these developments at the end of the 19th century then lead to this physicists like Hertz, Helmholtz, Boltzmann searching their own philosophy? Or that's how the Vienna Circle would put it in Frank's book, Physics and its Science and its Philosophy. And your narrative is the other one, but the same relationship, because the philosophers still thought that the problem was coming from physics. And they agreed on that. So they thought that they were the philosophy of that physics. Now, of course, physics means totally different things in the respective contexts. But in the way that you have a situation that's not always there, that there seem to be some people in philosophy, and also philosophy means to something different, and philosophy of science is not yet born at all in the late 19th century, but they agree that the answer of the problem comes from science. Now, if you agree on that parallel, that also tells, of course, that this is the perspective of the narrative that you're telling about a century where philosophy means something different and physics means something different. But in a way, you think maybe we are facing the same situation back then as 1930s, 1950s philosophers of science thought would be existing before it went the specific subdiscipline, etc.
Comments on this? Marius?
I have to think about this. This is a big question. Maybe I can follow up by email, Michael, but I have to think about it. Very interesting. Yes.
Right. I think we are kind of approaching the end of our discussion, and I would. I think I have the feeling that I have that I've skipped questions that are important. So if any of you seems very unsatisfied by the fact that I haven't noticed your question, now is the moment. We have a couple of minutes to take questions that were overcome that I somehow didn't notice. So maybe you should just raise a hand if you have unanswered questions you didn't have the yeah. Terry Bristol. I didn't mean, yeah, wait a moment. You need to turn on your microphone. Yeah.
Yeah, so wait a minute, there's something in the middle of my screen here. Yeah, so I've been working on this, couple of things to say. One is there's a great work by, very underappreciated work by Wilson Scott on the collision stuff. Antonio Drago and I have been working on this, and Drago, this changed his whole view of what's been going on. It's all about hard body and elastic body collisions, which have very, very different conclusions. And this goes up through briefly into Lazare-Carnot, which has been our focus. And I think that you'll get a lot out of Lazare-Carnot. And a number of people have come, so it starts maybe with Leibniz, Maupertuis, Euler, but it's Lazare-Carnot that gets it right. And really this is, a lot of people don't know about Lazare. They know Sadi-Carnot, this is thermodynamics. But everything that's in Sadi-Carnot comes from Lazare. It's all there in Lazare and his fundamental principles of equilibrium and motion. And it goes from Lazare through up into Coriolis and Navier, and then it's picked up by Duhem and Mach and those people in some versions, but not really. So the general thing, Peter Atkins, who's at Oxford, thermodynamics guy, starts out saying, well, look, there are actually two histories. This is a historiography question. There are really two histories of thermodynamics. One goes back through, Boltzmann and Clausius and stuff like that. It's the mechanical version. They try and translate thermodynamics into mechanics. And the other tradition is through Carnot. That's engineering thermodynamics. And engineering thermodynamics, and if you like, rational mechanics version of thermodynamics, are completely different. And they have different historiographies. Cardwell is onto this too. And then that opens him up into the history of machines. It's really the history of engines, which have to be distinct from machines. Engines actually have agency. So anyway, I don't want to, I'll leave it at that.
This is Wilson Scott's book. Yes. It's a very important book for our project. Absolutely. Yeah. So we have a different framework through which we're looking at things, but what he has to say about hard bodies and conservation, and that the part of the book that covers the period that we're interested in, is super important. As for Lazare and Carnot, I should hand you over to Marius, because he's been insisting that we have to go have a longer time period and things than we were originally envisaging. But he knows more than I do about that.
Marius, also by way of conclusions.
Yeah, so Carnot will be in the book. Stay tuned for the big sequel. It's a franchise, people. What you see right now is just as it were an extended trailer, as it were. But it seems to me that so Terry's question goes more to the broader historiographic question of who is the real creator of thermodynamics, and what ought we to count as the real birth date of thermodynamics. Is it this tradition that starts with the younger Bernoullis, that seek to show how, what we might call heat effects at phenomenological scales are really just like micro collisions between things, and that gets picked up by the, later the Laplace and the molecular matter theory people? Or is it this engineering tradition where, fire has a motive power and it sets machines in motion, and there's a Carnot cycle, and you can talk about rendement and heat losses. And so yeah, your point is well taken, absolutely. But it's a little bit oblique to the problematic that's driving, this paper that we.
Yeah, could I just make one last comment? And was that so? I think that if you want to trace the thermodynamics back further, my opinion, it goes back to Leibniz is probably the best. And the key thing is this idea of there's internal energy or agency as it comes out, internal energy in the system. So the traditional physics is always, something, in order to change a system, something has to come from the outside. This is Newtonian sort of stuff. And the Leibnizian thing, and I think Maupertuis gets it as well, that they change the framework within which mechanics is to be understood. The other brilliant paper, which I recommend, of Lazare Carnot's is this treatise on infinitesimal analysis. And that's crucial to the whole thing, because Maupertuis and Leibniz see there's like two sciences, or there's two different mechanics going on, and they can't resolve them, mv squared. And Maupertuis says, hey, it's got to be both at the same time. And incidentally, Max Planck was obsessed with Maupertuis, which then he realizes, he says, oh, wait a minute, it was Leibniz. But the complementarity in modern quantum theory goes right back to that, what Maupertuis and Leibniz see as this sort of dualistic characteristic of the system. So that what really goes on, the action idea, action is always composed of an irreducible component of each of those two. Now, trace that forward, it goes into engineering thermodynamics, and I would suggest that quantum theory isn't a mechanical theory. That's because that's what they're doing. There's their game. But quantum theory is actually a thermodynamic theory, and it's only properly understood from an engineering point of view, which is where the observer comes in. It's an actor, it's a person doing work. Work is an action. You might look at, I don't know if you know, Agamemnon Oliveira, as the history of the concept of work, does very well on this. Anyway,
I'm sorry to intervene here, but we really have to wind this down. And before closing, I would like Dan Garber wants to make an announcement for next week. Dan, you need to turn on your mic.
Thank you very, very much, Donna. First of all, I want to begin by thanking Donna for having done really a great deal of work in getting us all together today, and also Claudia Dumitru, who has set up a lot of the apparatus that we needed to do this. I'm just delighted at what was marvelous, marvelous discussion and a great way of starting this new project off. We now have, as of yesterday, a listserv of our own with which we can inform people about our activities. Over the next week or two, we will try to put as many people as we can onto the listserv. And if you're not on it within a week or two, send us a note and we will put you on. Next week, same time, same place, will be Justin Smith, who will be talking on something very different. Leibniz, Timasius, and Capitan on freedom and slavery. So we hope that many of you can join us next week. Donna, do you have anything you want to add?
Thank you. Yes, I just wanted to say thank you, Katherine, and thank you, Marius, for starting this off. It was wonderful. I would like all of you now to turn on the mics and maybe clap a bit for our speakers tonight, like this.
Oh, thank you.
Thank you.
Thank you both.
Thank you all.
Thank you, Dan and Dan.
Thank you all.
All next week. See you all next week. Bye-bye.
It was fabulous. Thank you.